Good morning, students. Welcome back. So in the last session, we discussed about the types of catalysts, the mechanism of catalysis, as well as the examples for both homogeneous and heterogeneous catalysis. So in today's class, we are going to discuss about adsorption theory of heterogeneous catalysis. Okay. So already you know that the meaning of heterogeneous, that means if the reactants and catalysts both are in the different physical state, then they are called as heterogeneous catalysts, and the phenomenon is known as heterogeneous catalysis. So let us see what is the mechanism of catalysis in case of heterogeneous catalysis. Here are few steps which comes under the mechanism of this process. So the first step is in the mechanism is diffusion of reactants to the surface of catalyst. You know, mechanism means the process will undergo in several steps. So it will not take place in the single step. It is not an elementary reaction or process. It is a complex reaction. Therefore, we have different steps in this process that is called mechanism. So it will be carried out in step by step process. So heterogeneous ಅಲ್ಲಿ ಫಸ್ಟ್ ಏನಾಗುತ್ತೆ ಅಂದರೆ ಡಿಫ್ಯೂಷನ್ ಆಫ್ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಟು ದ ಸರ್ಫೇಸ್ ಆಫ್ ಕೆಟಲಿಸ್ಟ್. ಯು ನೋ ದ್ಯಾಟ್ ಅಡ್ಸಾರ್ಪ್ಷನಲ್ಲಿ ಒಂದು ಸರ್ಫೇಸ್ ಇರಬೇಕು, ಅದರ ಸರ್ಫೇಸ್ ಮೇಲೆ ಅಡ್ಸಾರ್ಬೇಟ್ ಆ್ಯಂಡ್ ಅಡ್ಸಾರ್ಬೆಂಟಿನ ರಿಯಾಕ್ಷನ್ ಆಗುತ್ತೆ. ಹಿಯರ್ ಸರ್ಫೇಸ್ that is catalyst surface will be acting as an adsorbent and the reactants are acting as adsorbate. ಸೊ ಅದು ಹೋಗಿ ಅಡ್ಸಾರ್ಪ್ಷನ್ ಆಗುತ್ತೆ ಸರ್ಫೇಸ್ ಕೆಟಲಿಸ್ಟ್ ಮೇಲೆ, ಕೆಟಲಿಸ್ಟಿನ ಸರ್ಫೇಸ್ ಮೇಲೆ ಹೋಗಿ ಅಡ್ಸಾರ್ಬ್ ಆಗುತ್ತೆ. ಓಕೆ, ಸೊ ಕೆಟಲಿಸ್ಟ್ ಸರ್ಫೇಸ್ ವಿಲ್ ಬಿ ಕಂಟೈನಿಂಗ್ ಸಮ್ ವೇಲೆನ್ಸೀಸ್. ಸೊ ಅದರಲ್ಲಿ ಏನಿರುತ್ತೆ, ವೇಲೆನ್ಸೀಸ್ ಇರುತ್ತೆ. You know that chemical process or chemical catalytic activity or chemical adsorption is highly specific. So based on that valencies, the reactants are going to bind with that valency and it will satisfy the octet configuration and it will proceed into the chemical reaction. So thus, first reactants will be occupying on the surface of the catalyst. That is a first step in the mechanism. Second step is adsorption of reactant molecules on the surface of catalyst. Okay, second ಏನಾಗುತ್ತೆ, ರಿಯಾಕ್ಟೆಂಟ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಒನ್ಸ್ ದಿ ಡಿಫ್ಯೂಸ್ ಅಲ್ಲಿ ಹೋಗಿ ಸರ್ಫೇಸ್ ಮೇಲೆ ಹೋಗಿ ಅವೈಲೇಬಲ್ ಆಗುತ್ತೆ ಅಂದರೆ ಕುತ್ಕೊಳ್ಳುತ್ತೆ, ಅದಾದ ತಕ್ಷಣವೇ ಅಡ್ಸಾರ್ಪ್ಷನ್ ಪ್ರೋಸೆಸ್ ಆಗುತ್ತೆ. ದೇ ವಿಲ್ ಸ್ಯಾಟಿಸ್ಫೈ ದ ವೇಲೆನ್ಸೀಸ್ ವಿಚ್ ಆರ್ ಪ್ರೆಸೆಂಟ್ ಆನ್ ದ ಸರ್ಫೇಸ್ ಆಫ್ ದ catalyst. ಸೊ ದಟ್ ಈಸ್ ಅ ಸೆಕೆಂಡ್ ಸ್ಟೆಪ್. ಒನ್ಸ್ ದೇ ಗಾಟ್ ಅಡ್ಸಾರ್ಬ್ಡ್ ಆನ್ ದ surface of the catalyst, then occurrence of chemical reaction on the catalyst surface through the formation of an intermediate. So here intermediate formation ಆಗುತ್ತೆ ಅಂದರೆ ಈ ಕಡೆ ರಿಯಾಕ್ಟೆಂಟು ಅಲ್ಲ, ಆ ಕಡೆ ಪ್ರಾಡಕ್ಟು ಅಲ್ಲ, ಇನ್ನೇನು ವಿತಿನ್ ಫ್ಯೂ ಸೆಕೆಂಡ್ಸ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಎಕ್ಸ್ಪೆಕ್ಟ್ ಆರ್ ಪ್ರಾಡಕ್ಟ್, ಡಿಸೈರಬಲ್ ಪ್ರಾಡಕ್ಟ್. ಸೊ ದಟ್ ಸ್ಟೇಜ್ is called as an intermediate. For this intermediate, the activation energy should be low. Hence, it is going to fasten the reaction. So this you have studied in chemical kinetics. ಓಕೆ, ಆ್ಯಕ್ಟಿವೇಶನ್ ಎನರ್ಜಿನ ನಾವು ಟೆಂಪರೇಚರ್ನ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಕೂಡ ಲೋ ಮಾಡ್ಬೋದು ಅಥವಾ ಕೆಟಲಿಸ್ಟನ್ನ ಯೂಸ್ ಮಾಡಿ ಕೂಡ ರೆಡ್ಯೂಸ್ ಮಾಡ್ಬೋದು. Both are responsible for reducing an activation energy. Activation energy is nothing but the energy required to reduce the to form an intermediate. Okay, energy required to form an intermediate is known as an activation energy, which can be represented with the symbol EA. Okay, energy of activation or activation energy. So you know that adsorption is an exothermic reaction. ಅಲ್ಲಿ ಒಂದು ಬೈಂಡಿಂಗ್ ಆದ ತಕ್ಷಣವೇ, ಇಲ್ಲಿ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಆದ ತಕ್ಷಣವೇ ವೇಲೆನ್ಸಿ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗುತ್ತೆ. ಸೊ ಆವಾಗ ಎನರ್ಜಿ ವಿಲ್ ಬಿ ರಿಲೀಸ್ಡ್ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ಹೀಟ್. So that's why it is called as an exothermic reaction. By utilizing that temperature also, the rate can be fastened. Okay. So next is, once the intermediate is formed, desorption of reaction products away from the catalyst surface. Intermediate ಆದ ತಕ್ಷಣ next process is, it is going to form our desirable product. ಈ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಆದ ತಕ್ಷಣವೇ ಏನಾಗುತ್ತೆ, ಡಿಸಾರ್ಪ್ಷನ್ ಆಗುತ್ತೆ. ಒನ್ಸ್ ದ ಪ್ರಾಡಕ್ಟ್ ಈಸ್ ಫಾರ್ಮ್ಡ್, ಇಟ್ ವಿಲ್ ಕಮ್ ಔಟ್ ಫ್ರಮ್ ದ surface of the catalyst. So that process is called as desorption, right? So by utilizing the energy which is released due to the chemical reaction, the desorption process takes place. So after that, once the desorption takes place, the product will be available nearby its surface of the adsorbent. So then the diffusion process takes place. Diffusion means it will go away from the catalyst surface and it will come out as a product, new product, and we will get back the catalyst without changing its chemical character as well as the mass, that is quantity. ಮತ್ತೆ ನಾವು ಆ ಕೆಟಲಿಸ್ಟನ್ನ ಸೇಮ್ ಪ್ರೋಸೆಸ್ಸಿಗೆ ರಿಪೀಟ್ ಮಾಡ್ಬೋದು. ಎಷ್ಟು ಸಲ ಬೇಕಾದರೂ ಸೇಮ್ ಕೆಟಲಿಸ್ಟನ್ನು ನಾವು ಈ ಪ್ರೋಸೆಸ್ಸಿಗೆ ಯೂಸ್ ಮಾಡ್ಬೋದು. So this process you can better understand with this diagram. You can see here. Okay. See, this is the structure of catalyst. Here you can see catalyst surface having free valencies. Whatever bonds you are going to observe here, these are the valencies freely available on its surface. And here what we have is A plus B are the reacting molecules. Now A and B have to combine together by utilizing the catalyst surface as a platform, and it has to create a product. E A and B ಏನಾಗುತ್ತೆ, they will come and adsorb on the surface of the catalyst by binding with the free valencies. Then what we are going to get is, here you can observe this A and B have combined together, adsorption of reacting molecules, second process. Okay, illi diffusion agutte, illi adsorption agutte. Then what we are going to expect is an intermediate. So A and B have combined, and also they are in combination or on the surface of the catalyst. So this is not possible, that is all together will be in the same product. ಸೊ ಆವಾಗ ಏನಾಗುತ್ತೆ, ಅದು ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಅಂತ ಕರಿತೀವಿ ನಾವು. ಇಟ್ ಈಸ್ ಹೈಲಿ ಅನ್ಸ್ಟೇಬಲ್. ಸೊ ದಿಸ್ ವಿಲ್ ನಾಟ್ ಸ್ಟೇ ಫಾರ್ ಅ ಲಾಂಗರ್ ಪೀರಿಯಡ್. ದಿಸ್ ಇಸ್ ಹೈಲಿ ಅನ್ಸ್ಟೇಬಲ್. ಸೊ ವೆರಿ ಸೂನ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ ಅ ಸ್ಟೇಬಲ್ ಪ್ರಾಡಕ್ಟ್ ಫ್ರಮ್ ದಿಸ್. Now once we get an intermediate, desorption of product molecules takes place. So this is going to combine completely and it will come out as a new product. Okay, here you can observe A and B were separate as a reactant, and once they come on the surface of the catalyst, they came out as a new product, that is AB. And here you can observe the bonds are free, the valencies are free again, and the catalyst will come back as it was used in the reactant without changing its chemical character as well as physical character. Okay, so this is nothing but the diagrammatical representation of the mechanism of heterogeneous adsorption or heterogeneous catalytic activity. So whatever we learnt in these steps, so I have explained that through the diagram. Okay, thank you students.